A very good evening to all of you. We shall get started with a lecture by Professor Ashok Misra. It's my pleasure to welcome Professor Ashok Misra for this first lecture under the scheme of AICTE Distinguished Professor Scheme to our institution, Sri Ramakrishna Engineering College. On behalf of the entire academic fraternity and the students of SREC, I extend a very hearty welcome to Professor Dr. Ashok Misra. It's my pleasure to introduce Professor to the gathering. Professor Ashok Misra is currently the Distinguished Professor at National Academy of Sciences, Indian Institute of Science, Bangalore. Earlier, he was the Chairman, India of Intellectual Ventures for a period of 8 years from 2008 to 2016. He has served as Director of IIT Bombay, again for 8 years from 2000 to 2008, at IIT Delhi from 1977 to 2000, and at Monsanto Chemical Company from 74 to 77. He is an adjunct professor at the University of Massachusetts and was a visiting fellow of Trinity College, University of Cambridge on 3 occasions. Professor Ashok Misra is an alumnus of IIT Kanpur for his BTech and MS from Tufts University and PhD from University of Massachusetts. He was conferred the DSc by Thapar University, Patiala. Professor has held several responsibilities with the Ministry of HRD, Government of India, including the Chairman, Standing Committee of the IIT Council for a period of 2 years, Chairman, Board of Governors of IIT Roorkee, Member Board of Governors of IIT Delhi for a period of 4 years. Professor Misra is an independent director on the Board of Directors of Kirloskar Electric Company Limited, Jubilant Life Sciences, Jubilant Pharma, and Higher Education Funding Agency since 2017. He was also the independent director on the Board of Directors of Relevance Industries, National Thermal Power Corporation, Rashtriya Chemicals and Fertilizers. Professor Misra is a fellow of National Academy of Sciences India, NASI, and was its president for 2 years, a fellow of the Indian National Academy of Engineering. He is also the founder president of the Polymer Processing Academy, former president of the Society of Polymer Science, and founder president of IIT Alumni Center, Bangalore. Professor Misra has received several awards, including the Distinguished Service Award of IIT Delhi, Distinguished Alumnus Awards from all his alma maters, University of Massachusetts, IIT Kanpur, and the Tufts University, Distinguished Service Award from Polymer Processing Society, Indian Chemical Council Lifetime Achievement Award for Education and Research. And Professor has also received the Bhatnagar Memorial Award at the 94th Indian Science Congress, Chemtech CW Awards for Education, and Acharya Prafulla Chandra Ray Memorial Award of Indian Chemical Society. Professor has guided 22 doctoral students, co-authored a book, has 16 patents, and 182 international research publications. It is indeed our pleasure and privilege to have such an eminent academician, academic administrator, and researcher amidst us today to deliver the first lecture on fostering creativity and innovation in science and technology to the audience in SREC, which has both faculty and students under the AICTE Distinguished Professor Scheme. I once again extend a very hearty welcome to Professor. Over to you, Professor. I request all the members to kindly mute, and once professor's presentation is done, the session is open for interactions. You could either pose your questions in the chat box, or you could also unmute and then talk one at a time at that time. Thank you very much.
Thank you, Professor Alamelu, for this very generous introduction. I think you've covered a lot of things that I've done in life. It's absolutely a pleasure to be presenting this talk to Sri Ramakrishna Engineering College. And I'm honored that AICTE has given me this opportunity through their scheme of distinguished AICTE chair professor. Well, first of all, I don't know exactly what is expected of me, but one of the things is to enhance interactions with several colleges, and I'm happy that the very first lecture that I'm giving is at Sri Ramakrishna Engineering College in Coimbatore. I do hope to visit your college sometime in person and see for myself, and because a lot of things can happen through interactions in person rather than over internet. But we've all learned to do Zooms in the since March 2020. I have not attended any meeting except for one. I take that back. Except for one in person, and that was very close to you at IIT Palakkad, which the chairman insisted that we come. That we all come for that meeting. That's another thing, that since IIT Palakkad is very close to you, I'll be happy to see if some interactions between your two institutions develop as you move along. Okay, so let me go to my presentation. Oh, I don't know what happened. Slideshow. Okay, from there. So, as you mentioned that you do have an innovation center, so some of the things may be actually not that exciting because you already do a lot of things, but then let me give my perspective of what I think should be done, and maybe you can take some guidance from that. In addition to that, there are several other topics that I talk on, including what should be the online education, this new paradigm as we move along, because that's there to stay, and perhaps on governance issues and so on. So let me start with this. My first slide. Sometimes we say that we are in a globalized world. Globalization is taking place, and it's a knowledge economy, and so on and so forth. What does that mean? This means that the advances in technology has led to this globalization and increased power of knowledge. Let us take the simple technology of the mobile phone and internet. In India, millions of people did not even see a telephone. And suddenly now they're in communication with everyone else around through their mobile phone. They are quite savvy in terms of WhatsApp and this, that, and the other. So when this technology was unleashed and shared with the world, it changed the whole system of thinking and communication. And this is what I call globalization. We call this current era as the knowledge economy, and therefore knowledge economy has to be global. What this means is that advances in productivity and other things are increasingly based on knowledge, which once disclosed spreads faster than capital or people. The economy thus becomes global. And in today's world, through online teaching and courses which are available online, like the Coursera and so on, or the NPTEL courses produced by the IITs and IIC Bangalore, they are available to everyone. And therefore, whether you're sitting in Ethiopia or whether you're in Kenya or Sri Lanka, it doesn't matter. that knowledge is available to you. How you use it is, of course, how that country utilizes it, how that institution utilizes it is their problem and their this thing to take advantage of. All countries stand to benefit when new knowledge is internationally shared. Again, like in the case of internet and mobile technology, and there are many more things. Now the vaccines are being shared internationally and everyone is gaining. If some country said, oh, this is my vaccine and I will not share it, then the pandemic will be worse in the world. All open innovation, therefore, occupies a very significant place in the knowledge economy. And I'll talk about this quite a bit. Alongside, we also have to be aware of the sustainability. Some of the problems that we see of very high floods and this and that is because, lots of things of dams have been built without taking into account what will happen if a landslide occurs. Housing has been built without taking into account how water will flow when high rainfall takes place, and so on. So sustainability, sometimes people don't take notice of, and therefore we should take care of that. So higher technical education, I'll stress on higher technical education because you're an engineering college. What do we do? What do we provide? What does a higher education institution provide? It provides education, and that is to develop technical manpower. Then it also does basic research and development, and this is to develop new knowledge, innovations, inventions, papers, all those things. Then there's some applied research where the research can be used to develop new technologies. Without basic research, applied research normally does not take place. So therefore, we have to be very strong in our fundamentals. And then we have to create inventions, innovations, and all these leading to intellectual property. This leads to entrepreneurship, technology incubation. Higher technical education institutions with a strong research focus will have a greater impact in the country in the future. Of course, developing technical manpower will be there, but all other things are also important. So therefore, research focus. You have to give high priority to research. Only then innovations will take place. For this, you have to have top-class researchers and top-class research facilities. Enhance interactions with the world outside, which is the industry. Like in your case, there are lots of industries in the Coimbatore area, one of which is the textile industry. Textile industry needs a lot of innovations if it has to compete in the world, and that is where institutions like yours can make a difference. Then commercial research for industrial development, that has to be done. And create intellectual property through new ideas that are developed through creativity and new inventions, new innovations. And I will distinguish between invention and innovation a little later. And research and innovation leading to, of course, entrepreneurship and technology incubation. Little repetition there, but just to make the point. So what is the importance of research? Here I would talk a little bit about science. Science is the base for the development of all technological and economic growth. Advancing nations have to be strong in science. All the advanced nations are already strong in science. So if you look at America, or you look at Germany, you look at France, England, where are the Nobel Prizes going in science? To these countries. Which are the countries which are making new technologies? It is these countries. So there is a link between high-end knowledge in science and the technological development. So you have to have a very strong base in science. Unfortunately, I believe in India, the science base is getting a little bit weaker. Lots of students, very good students, don't want to go into science. Good technology has to come from good science. It is imperative that we in India emphasize the importance of science for technological development. This will enhance the level of education and research in science and technology at the higher technical educational institutions like yourself. Just to give you an idea, I don't know if you know these numbers, but it's nice to repeat them. We produce approximately 50 lakh students at the 12th class level in India. 50 lakhs is 5 million. 5 million is more than the population of several countries. Even a huge country like Australia has only 10 or 11 million. So that many students, half of Australia, we are graduating in science in the country. And if you say that 10% or even 5% are of world-class level, we should have an abundance of science and things coming out of the country in terms of scientific knowledge which is being generated. But we see that it's not happening. In fact, what we see is that many research laboratories in the country many times are understaffed and don't have enough scientists. What's going on? Something is going wrong. We have to correct that. Systems should provide ample opportunity for creativity, innovation, and generation of new ideas at all levels. Okay, just to excite mainly for the students, scientists who we are proud of in the world who have made and changed our lives. Isaac Newton for gravity. Now you can say, okay, he did only gravity, but all the principles of gravity are the ones which are used for by the space research, how to overcome this gravity to send spaceships, rockets, and so on in the orbit outside the Earth. Basic knowledge, very basic knowledge. I'm sure Isaac Newton was not thinking of space research at that point, but it's useful. Alexander Graham Bell, he had the telephone. I'm sure he had no idea this telephone will take us to so many million people through the mobile telephony. Our own Jagdish Chandra Bose did not get a Nobel Prize, but he was actually the inventor of wireless transmission of information. And it is believed that he said, oh, why do I need it? I can go home and talk to my wife. Why do I need a phone to call home? And he also proved that the trees have life and so on. Very, very basic fundamental science. Madame Curie did the radium, which is well known. John Longbear did the television, and when he did the television, I'm sure he had no idea that today the television would be just a flat piece of electronics which you hang on the wall, because he was thinking of cathode ray tube and this and that, a huge bulky this thing. And in fact, if you look at your, many times I was watching Olympics because I was not home on my cell phone. Basically, it's nothing but like a mini television. And Alexander Fleming, the first one to bring out the penicillin, and which led to a lot of other vaccines and the like for the world to take advantage of. We had our own C.V. Raman, did molecular scattering of light, which was very important in terms of studying materials. John Elders did the polio vaccine. Martin Cooper, the mobile phone, 1973. Look at the mobile phone he has. It's like 10 times the size of what we use today, and probably 1,000th or 1/10,000th less powerful than what we have today. I'm sure he had no idea that it will reach that stage, but these are the inventors, and the rest is innovation as we go along. The people who do the first science and first thing in the world, they are the inventors. The rest is all improvements and innovations as we move along. And I like to show this slide because I saw this movie, Hawai Zada, a Hindi movie. It's an okay movie. It's not a great movie, but it's a good movie. And it talks about the life of Shivakar Bapuji Talpade. He was an Indian scholar, and he is said to have constructed the first unmanned airplane, which flew over Chapati for a few minutes, for 20 minutes or half an hour or something like that. 8 years before, the American siblings Wright brothers had a plane. Why is it not known? Because a lot of that information is buried, and I've tried to dig it out. It's not easy to get, but apparently he was a Sanskrit scholar, read the Vedas, and he apparently acquired knowledge about how a plane works from Rig Veda. I've tried to read it. It's not easy. This was the kind of thing which is lost. The movie. Hello. So it is believed that the British said that Indian cannot invent a plane, so therefore they hushed it up and did not let it come out in the open. Yep. Please keep yourselves on mute. That'll be better. Okay. So these are the things that, and this inventor just went unheralded. I've got some information, but it's not easy to get that information because apparently the British did not allow that to surface, saying that how can an Indian think of a flying machine and that sort of thing. And that is what is depicted in the movie also. Okay. Then there are people that are who made a lot of difference in our. Robert Noyce did the integrated circuit, which has now gone many times better. Bill Gates, first operation system after the human brain with all the software and so on. James Watson did the DNA, which has changed the way how people look at the body and how they can say and cure this through the DNA structure. Our own less known to us is Sanjay Kohli, who is the architect of the mass market GPS. We look at GPS to Google Maps and so on and so forth. Sanjay Kohli, his father was the person who started TCS for the Tatas. So he gets to be very well known because he did that. But Sanjay Kohli somehow not known. Craig Venter did the genome sequencing. Robert Langer at MIT, the drug delivery. And Steve Jobs, the Apple phone with its innovative things in it. And he said that a lot of times people don't know what they want and you have to show it to them. That's an inventor. That's the philosophy of an inventor. Needless to say, there are hundreds more examples, but I just wanted to point out the ones which are more open to us in terms of what we use today. So the earth still needs invention at all the times. We have to address the digital divide, which we are doing currently. We need food and resource management. There is still hunger in the world. There is still a lot of food which is lost in India itself by not proper storage mechanisms. Water, you think water everywhere, but anytime you look at water crisis is everywhere. Bangalore has water crisis. Goa has water crisis. Delhi has huge water crisis. You get it only few hours a day and things like that. Energy generation and its distribution. Generation is, just to give you an idea, those of you who may know or may not know, when you burn coal, the energy that you get is only about 36-37%, maximum 40%. 60% of coal, when it is burnt, that energy it produces in terms of heat is just lost to the atmosphere, just lost. Can we not do 60%? Can we not do 80%? Lots of work is required, and how you distribute it is another problem. Healthcare, I don't have to tell you about healthcare. In the last 2 years, we have seen, although we think we are such an advanced society, civilization, but COVID has shown us that our healthcare throughout the world, not just in India, leaves much to be desired. Waste management, we are consumers, but we waste a lot of stuff. Lots of dumps are full with stuff. We don't, as civilized people, sometimes we don't think of what's happening to our waste. For example, you all ride cars, but you don't know, after you change the car tires, you don't know what happens to the cars, and many people don't even, most people don't even care what happens. It cannot be burned, it cannot be buried, it will just go into a dump and keep on piling up. But you got to buy a new tire because there are companies that are making new tires, so the problem is not solved about how to take care of tires. So just as an example, and there are many other things. Then ecological balance, and you're seeing all these floods and this and that is taking place. We don't know how to take care of it. Terrorism is still going on. Even yesterday, today, you hear there's so many people killed, terrorists killed so and so. Afghanistan, our border, and whatnot. How do we counter this, this menace that is going on in this world? We need some science and some technology to take care of this. So we say this is a golden age of invention. No, it's not. The golden age of invention was 50 years ago, 100 years ago. It depends on which age you are living in. And even today, it's a golden age of invention. So it's always be a golden age of inventions because new things will keep on coming out. What camera used to be, it's made different from now. What movies used to be has changed. Now with Netflix and all that, cinema halls have become defunct. Radio, recently went to a village in Himachal, and there we heard a radio after like decade because there that was the best way to get some news. But radio, many people don't even, youngsters may not even know what a radio looks like. Light bulb has changed from one time to the other. Surgery, different kinds of surgery, invasive, non-invasive, this, that, you just put a laser thing inside, orthoscopy and so on. I don't want to read all of them. Aeroplanes have changed hugely. Television, I already mentioned. Integrated circuit. Now you can put millions of chips in 1 square centimeter. When integrated circuit was invented, they probably couldn't imagine that this could be done. And if it goes to quantum computing and biodots and all that, it may even be. We don't know what is the future. So this is just a light bulb. My father, when he studied, he says he used to study sometimes with the lantern, which is equivalent to this. And then this incandescent bulb was there for the longest time. And now you can't even buy so easily in Canada sometimes. And then the CFL came, and now very soon it has become obsolete. And now we have LED and whatnot. Also, we have to make sure that we can dispose them of properly after they're done, and there's no hazardous side effects when it is disposed of. That's what I meant by sustainability. We talked about mobile phone, but today everyone is a photographer. I collect cameras, so I have this camera also. Youngsters will not know, but some of the older ones will know. The photographer used to come, put a black cloth on top of his head and the camera and say smile, and in 2 seconds one picture would be taken on a plate and all that. Then came the box camera, then this lens camera, much improved, then the single lens camera, and so on. Now I have a single lens camera. At this, when I bought it, it was one of the best of its kind. Today I can't get a film to put in it. All Kodak is all gone, And now everybody is a photographer with a mobile phone. Okay, what happens is scientific inventions drive technology. All technologies begin with some sort of a scientific invention and then technological innovations. Invention drives technology markets. Communications, we have had the telegraph, telephone, cellular, internet, all that mentioned. Information technology, now we are talking of AI, artificial intelligence, machine learning, and whatnot. Even I don't understand some of it. Biology, some of the biology is so complex and so huge that I don't know much biology anyway, but it's become all very, very complicated. We have to develop, they talk about vaccines and they say this is this DNA, this is that DNA, this vaccine is based on RNA and whatnot. It's mind-boggling. So we have to develop intellectual property that will give enormous social economic benefits for the country and the world in, as we said, it's a global economy, so to the world. What makes a good invention? What is an invention? It's an act or instance of creating or producing by exercise of imagination some sort of and I call it a technical device, but it need not be. It could be a drug or it could be something else. Should be protectable. That means nobody else has done it before, so you can protect it. It's intellectual in origin, inevitable, beyond the obvious. And good inventions can come from anywhere. Anyone can be a good inventor. It can be a researcher, a faculty member, employee, entrepreneur, or just a guy in the garage, who is fixing motorbikes and things like, or a student. So not easy to define. A lot of people make this not do not make the distinction, but I look at it as invention being its foray of the unknown, something which was not known before, and you come up with it, so it becomes an invention. Innovation is putting together the known for novel effects or improving upon the invention that you have. Most of the things that you see around are innovations. So, like as an example, when today we take it for granted that you have so many chips, so many transistors, so many things on small chip. What is that chip made of? It's silicon. That silicon, when it was developed, is the basis for everything to follow. So that is a real invention, how you can write on that chip, which can be used instead of the big diodes and triodes that which people had earlier. And then, of course, how to make more chips on a smaller surface, how to etch the surface and all that. It's all innovation of the highest order. But somewhere when you have a new method to write on that chip, then that becomes invention. So, for example, you look at this water jet cutting machine. What is the basic principle here? It's a scientific principle. What the scientific principle says is that if you have any fluid at a very, very high pressure, it will have such a force that it will cut anything. And in fact, that's how people did it. They had a boiler in which there was a pinhole and somebody just had his hand, the worker's hand went across it and the fingers were chopped off because the pressure, the force was so much. So that's a physics principle. There's no engineering in it. But then to convert it into, then to convert it into a machine which will have very tiny orifice, which will force liquid through an orifice at a pressure which is so high that it will cut metal, forms a water jet cutting machine. And I've actually seen this. Many of you may have also seen it, those who are mechanical engineers. But for the first time I saw it, I said, what, water is cutting metal? Impossible. Physics, that is the basic. Mechanical engineering is the technology to make that happen. Elastomers. So, and I'm in the area of polymers. So I give this example. Till the rubber that you get from the tree or polybutadiene, which you make in the reactor, till it was cross-linked to make an elastomer. So what's an elastomer? If you take a rubber band and extend it and release it, it goes back to its original shape. That's an elastomer. When you have chewing gum in your mouth, it's just rubber. You can extend it, but it will not go back to its original shape. And that's just a rubber. So actually you're chewing rubber when you're chewing gum. Why it feels so good is because it's at the right temperature and it's got sweetness and all that. But really speaking, it's just a rubber that you're chewing. So Goodyear invented the vulcanization, that means cross-linking of the rubber to make polymers, which will give you cross-linked elastomers. Rubber gained worldwide importance with the invention of air-filled pneumatic tires, which was developed by Mr. John Dunlap. Both I believe were in England. And together with this, you had a tire and a tube which you can put on a motor car, on a vehicle. Before that, there were horse carriages with wooden wheels. There was no rubber, there's no tires and so on. And then that it revolutionized the automobile industry. People don't think about it, they think of engine, this, that, and the other. All that is important. But if we didn't have this rubber tire and tube and tire, now there are tubeless tires and so on. The cars will not be running on the roads. So, so the invention was the cross-linking of the rubber, never known before. But innovation is that you improve the tire. Now you have tubeless tires and you have steel belted tires and you have tires which can run on snow. There are tires which can run in rough terrain and so on. Those are all innovations as we go along. A tire lasts, today when you buy a tire, it lasts almost 50,000 kilometers. Earlier tires are only 10,000 kilometers. And these are all innovations that you go along. But the basic fundamental was the cross-linked rubber. If it wasn't there, no tires, no cars running on road like we know it. We'll still be in some sort of wooden cart wheels and so on. Today we are talking of even self-healing paints to make cars scratch-free. And since we are talking about cars, this is invented in England. It's this paint is on it. You put a scratch, and normally when you buy a new car and the first scratch comes, you feel really bad that, and then the second scratch, you feel less bad, and then 10 scratches, you say, oh, it's part of life. But this has a paint which is self-healing. You put a scratch and it'll go away. And after, within half a day or so, by flow of polymers. And then after 2 months, again, same place, you make a scratch, again, it goes away. So these are the innovations that are going on. The invention was the paint. And then now invention is a polymer which will reheal itself, self-healing polymers. So the number of areas in which we can have inventions, and I won't read all of them. Some of them I have already mentioned earlier. I'm happy to share the slides with you later. Automotive technologies, lots of things are going on. When I was growing up, and many of you will remember the old Fiat and Ambassadors and all, the bumper was always some heavy piece of metal. Today it's all changed. It's all fiber glass reinforced polymer. The inside of the vehicle, the dashboard, used to be wood sometimes and so on. Now it is all plastic. Fuel injection system has come in. There are sensors which will sense lots of things in the car, and it will tell you now the petrol is so low and so high. In fact, even in India, the cars will tell you that pressure in such and such tire has gone low. All those sensors have been put, so you go and get the tire filled with air. There are airbags and so many things like this. And the windshield that you have is a composite material between two glasses and a polymeric layer which will make it shatterproof. So lots of innovations in cars are going on, and every year new models come with new things in them. Nanotechnology, I'll not take too much time on it, but it's a how, not a what. Nanotechnologies is all kinds of areas. It's in engineering, energy, catalysts, electronics, information technology, sensors, optics, material science. Carbon nanotubes are there, which are reinforcing and very unique materials. So that are the 10 top nanotechnology devices. This energy storage is there. Agriculture productivity, because there are nano fertilizers, which are more effective. Then there's water treatment can be done, disease diagnostics and screening, drug delivery systems, food processing, air pollution, construction, health monitoring, vector and pest reduction control. So lots of nanotechnologies have been used in today's world. This is my favorite center of flexible electronics at IIT Kanpur. Not because I am an alumnus of IIT Kanpur, but this is one of the best centers for work on flexible electronics in the world. Mark my word, I'm not saying India, in the world. They have combined people from various disciplines of material science, electronics, chemical engineering, and so on to develop OLED displays, printable electronics, organic solar cells, printable inks, memory devices, sensors, and so on. All this, as these come into play, it will change the way electronics are. Of course, the ultimate in flexible electronics from a consumer point of view is if you can have a cell phone which you can fold and it's flexible and you can just put it in your pocket, or you can have a computer which you can roll up like a calendar and roll it down on anywhere you want rather than carrying this heavy thing and so on. So these are the possibility. Water management, we need cost-effective desalination, low-cost filtration system, reusing of plastics, recycling of water, and many operations. One is the elimination of water in the dyeing process, as I mentioned about the textile industry. Dyeing is a very important part of the textile industry. Can you do it without water or less water? Otherwise, lots of water is wasted in this process. Energy, we have coal gasification technology in thermal plants and improvement in efficiency, and I don't want to dwell too much on it. Solar power is working towards grid parity, and now it's become solar power has become quite inexpensive and so on. In fact, in my house also I have a solar panels on top to give me some electricity. The solar photovoltaic cells are there, expensive. Every solar cell that you have, it's the machine required to make it is huge, and it itself has a carbon footprint. So it takes carbon footprint to make the solar cell, which is supposed to reduce carbon. So are we gaining or are we losing? Somewhere we should gain. If you can make solar cells of organic materials like polyesters and coat them, things will become cheaper. Even if they are less efficient, they'll be much more efficient in terms of energy saving. And of course, power distribution is another problem. We all know about power thefts in India. How can we prevent it? And I mentioned to you earlier that when you burn coal, let's say 36% you get an energy out of the coal. In the transmission, there are losses. Let us say there's no theft, even then there'll be some losses. So by the time it reaches your home, it's about 30 or less percent, 25%. 75% of coal that is being burnt. People talk of all kinds of technology. We are not harnessing that at all. It's just going into the atmosphere, lost. That efficiency we have to improve. This is some young entrepreneurs from IIT Roorkee who have made this called Log9. Company is called Log9. And they made aluminum air battery architecture. And it's shown here. And that can be put in a car. And what it requires is that you put aluminum electrodes and put water, pure water, distillery water is good enough, and it will go for 1,000 kilometers. And after you go, there's no charging required, no electricity charging required. You change the water, put new aluminum plates, and it will go another 1,000 kilometers. So they've done it in the prototype scale. Once it goes to the higher level, it can change the whole technology. This I'm giving some examples of what's actually going on in India. Then my young friends from IIT Kanpur are making some nanofiber for air purification, and all this is there. They'll help problems with respiratory lung disease, leukemia. A lot of people have asthma and so on, so they can help in that. And the advantage would be protection of respiratory diseases. It will support cardiovascular problems, liver, and other things. And this technology, which you can put in your window to protect those people who are lung problem or asthma problem, will be useful. And then the same company has developed very nice nanofibers, nano hollow membranes, which can be put inside. And I'm sure you are familiar, you've heard of Tata Swachh water filter, doesn't require electricity, and I use it not here, but in places where one spends less time. You can take this along with you, put water in it, and you get fresh water within an hour or so, without any energy requirement. Then air purification and antivirus, anti-pollution masks have been made by again nano filters, nanofibers, and this will can be put. These people have developed this even before COVID for pollution. So people were wearing this in Delhi for pollution because they were getting problems of breathing and so on. Now suddenly COVID came, so this has become even more relevant. Again, one company which is led by IIT Delhi professors, actually a student of mine who's a full professor there, to make nano-safe masks, which are 4 layers, which have an antimicrobial layer also inside. And these masks are very, very good. I have some of them. You wash it and use it for at least 2 months, it'll keep on going. And then plastics at a time of pandemic, we were all saying single-use plastic, throwaway plastic, this, that. But in the pandemic, you needed the suit, you needed the gloves, you needed the masks, you needed the shield. They're all made of plastics and lightweight materials which can breathe also, but also prevent from corona going, especially for health workers and for some of us who once in a while travel. I wear these gloves and I wear this mask, double mask, and this, that, and the other. These are all innovations which have come up within the last year because of the pandemic. We have this water, I should have put this slide earlier, but I put it here. You have these solar panels. One of the problems is that dust collects on them. And that happens and efficiency of the solar goes down. So this company has made a device which will clean the huge solar panels. See, I'm not talking of like 6 panels in my house. I'm talking of hundreds of panels where in the desert areas or wherever big, huge solar plants are being made. So this is how people are thinking. I'm giving you some examples of examples. This is a company which, again, in IIT Kanpur, and what they've done is they call it pool.com. They collect all the flowers from all the temples in the Kanpur area and process them to form equivalent of styrofoam. This is all packaging material that you see here, made out of recycled, reprocessed flowers. Very innovative in their thinking. And ultra-touch jeans insulation would be nice if we can turn these jeans into some sort of an insulating material. Same idea as the pool technology. When you throw away jeans, normally they just go burn somewhere, but you can reuse them and use them for insulation in the houses by converting them into these foam type materials. You don't need styrene, polystyrene foams. This letterbox, just to give you an IIT Bombay professor, designed this letterbox, which changed how the letterbox looked for many, many years, maybe 100 years. Little safer, little better, and the like. Then IIT Bombay people developed this device. This is a little more crude version. Now they are much more sophisticated version that you wear on your body. It monitors heartbeat and so on. And the moment there is a heartbeat problem, it sends a signal to your doctor that, this person may have a heart attack. So the person may not realize he or she is having a heart attack, but the doctor immediately calls that you better go get some medical help. And there are technologies developed by another professor, all kinds of, I'm running out of time, so I won't go through these details, but affordable glucometer strips, so you can test your own diabetes and blood sugar and so on at your own time. Put it in a device through a Bluetooth. You can send it to your doctor, and you can get. I'll skip this. There's lots of. Now the other one other thing is the smart windows. So what happens is that if you have these windows and you put a layer of unique liquid crystal film, then the liquid crystal film can orient in such a direction that it becomes dark. It's similar to what you see in a cell phone. When you see the numbers 1, 2, 3, 4, it's because of orientation of the liquid crystal in one direction, and then a polarizer on top. It becomes dark, so you can see the letters 1, 2, 3, 4, A, B, C, D. Same sort of technology that you can apply a little voltage to this window, and it becomes dark. So you don't need any curtains. Also, you can have something that instead of becoming dark, it can become opaque. So in the windows also, you don't need curtains. You you need privacy, just put a little switch on. The liquid crystal polymer goes from clear to hazy, and you can't see through. Since you are in the tea coffee belt, I'll just mention this. Coffee, when you make coffee, there's a little seed inside which gives you the coffee. But there is a cherry, which is a lot of water. If you remove the water and make a powder of it, you call it coffee flour. So for each cherry, the amount of coffee you will get an equal amount of coffee flour. Although the cherry is much bigger, but a lot of it is water, and therefore the amount is less. And this has been used for cereals, cookies, and several edibles. The advantage is it has got a lot of proteins. Otherwise, cherry was just being thrown away as a mulching material, and also is gluten free. So those who have gluten problem, they can benefit from such materials. Then joint replacement. Look at the technology of joint replacement. How many different kinds of materials are used for that? This is a very recent company started by an IIT Bombay person called Biko, and you can Google it. It brings robotics and AI to every consumer home. So these are Miko robots, and I have bought these got these for my granddaughters who are about 8-9 years old. Talks to you and keeps you engaged, and you can do math sums, you can do science, you can do rainbow. What are the colors of the rainbow? There's all kinds of things it does. It costs a little bit. It's about $250, $300, but it's absolutely wonderful for a child to learn from it. And in today's world, when a lot of children are single children in the family, they don't have a sibling who to talk to, this also becomes like a companion. So the people who do this, they were told that you should also make one for adults, because today's world, there are a lot of adults who are lonely and they need some partner. So this is like a partner with a child should be a partner with an adult also. So normally we have the traditional path for growth. Every country starts with natural resources and heavy industries, and finally, and ultimately, innovation and high value services. And this just gives you a typical idea that these guys who never saw a phone are now doing all their business, and they are empowered to earn more money through the cell phone that they have, because they are in touch with what are the prices of onions and sabji and whatnot. So we have a potential to go straight to this path. Can I go 5-10 minutes more, or Professor Alamelu? Hello?
Sure, Professor. Definitely, yes. Yeah.
Okay.
You can.
Okay. So this in India, we are proud of this UID, what we call as the Aadhaar number. Okay, it's the world's largest database management. We just take it for granted. Aadhaar number, de do, ye kar do. But you don't realize that this is the largest database management project in the world. It's aimed to give UID numbers to, well, now it's much more, but we are talking 2014. And this as an example, 600 million people. What this means is that you have to provide a 12-digit number, and for that number, you have to take 600 million photographs, compare each photograph with all the others so that there is no duplication. So 600 million photographs are quickly scanned with 600 million minus 1. Just imagine how fast that computers would be. Same thing with the addresses, irises, 2 times, fingerprints. I collect fingerprints are 6 billion because 10 fingerprints are there, so it's 10 times more. It's an absolutely mind-boggling thing which our own Nandanil Kenny and his team did it in the country. Other countries are still struggling with it. So Indian science is competitive. We have a huge opportunity. We should take things in a mission mode. And what we are saying is we should have fundamental science, applied science, all this business, technology, business, market, wealth, and increase the GDP. And of course, there is science and there's technology and there's directed science. So you see in each country, because that you have to do country specific, You say, okay, these are the problems I want to solve. We want to solve in India. Nobody else will provide you the solutions. We have to develop it ourselves. A very simple example is everywhere in the world, well, most places in the world, you get pressurized water. In India, we don't. So therefore, we have this one overhead tank, and sometimes pour water won't go to the overhead tank. Then you have to have a tank below the ground, then pump it up to fill it up. All that business. Nobody else in the world will do it, but we have to see what is the best way to do it in the country. So therefore, we have an ambience for creativity, develop new knowledge, new ideas, intellectual property for public good or for wealth creation. So one of the two aims should be there. Either it's for the good of everyone or you create wealth, or in sometimes do both. So here we go to R&D, to prototype, manufacture, sales, marketing, and wealth creation, company formation. And for this, we require, this is often called as the death valley, that you have very good ideas and all that, but nobody supports you. You don't get, very difficult for inventor to sometimes explain to a venture capital company what my idea is. And if you don't get that, gone. But if you can get out of this, venture capital believes with you, somebody puts you some money through the angel investing, the venture capital, then you can keep on going. Just to give you an example of a company called Happiest Minds. Okay, Happiest Minds was it went for IPO in September with a share price of 350, 360. September, October last year. Today, its share price has soared to 1400, 1500. With the kind of new technology that they have come up with, they went through this death cycle and now they are soaring. And the end, this is the last slide, the most beautiful thing, and I'm just taking some quotations, they're not mine. I wish they were. The most beautiful thing we can experience, but I believe in them, is the mysteries of nature, is the source of all true art and science. Both things are happening in the nature. You go to see some wonders of nature, absolutely mind-boggling. And imagination is more important than knowledge. You have knowledge, but you have to let that imagination run a little while based on your knowledge. And then my very senior friend, Nobel laureate, he said science is people. Very simple words. He gave a very nice talk. See, science is not coming from the heavens. It is coming from our brains. So if we invest time and money in the brains of the people, science will come and science will lead to technology. So science is people. All the right questions in nature will open the doors of our secrets, and that's what our own C.V. Raman said. And then Peter Drucker, the management guru, says, if you want to understand the future, we have to create it. So therefore, generation of new knowledge, outstanding research, productivity based on innovations and inventions, research and creativity is the heart of the economy. Invest in people, focus on India's long-term economic strategy. So to influence the future of the world, science and technology should ignite a million minds to just take us forward. And in India, we do have those million minds, fortunately, which many countries don't have. So, okay, thank you. That's it.
Thank you very much, Professor. Any questions? Probably I will start with the question. Professor was mentioning that huge number of kids completing their 12th class, but only very few of them take or opt to read science. What do you think could be done by people like us from higher education institutions to create a better awareness on science, which is the fundamental for technology, to school kids Maybe we need to catch them a bit early when they are in their 7th class or 8th class. What do you think that we could do from our side? Professor, you are on mute.
I'm sorry, my mistake. Okay, so I think I went to unshare, so it muted me also. So there are several things. National Academy of Science India, NASI, does a program of popularization of science. So our fellows go out to very many places, not just the metropolitan cities, metropolises, but also to other cities, and we can arrange to have these people go in schools, colleges to excite the students in careers of science. That's number one. Secondly, the mindset of the Indian parent, which is very, very important, has to change. Somehow it is embedded in the parents' minds that if you don't do engineering or medical or something like that, you are wasting your time. Absolutely wrong. You have to see where the talent of the child lies and let it go with that. People don't get into the JEE exam and say, oh, everything is lost. Everything is gained because now you can go into science because you didn't get into an IIT or any other JEE led examination. And the third thing is the country has to also honor the scientists, make sure that wherever the science jobs are there, they are well paid. Okay. So several things have to happen. It's not just a single problem. NEP should have addressed this problem, and I'm afraid they didn't. NEP, I mean the National Education Policy.
I know. I understand that. See, because most of the time we feel children to be really good in science. Since they do not have the right inputs at the right time, they miss the opportunity. They miss that opportunity.
Yeah. So what you should do at your institutions like you, so if you have any idea of IITs, IITs have very strong science departments. So IIT Bombay, IIT Delhi, IIT Kanpur, all other IITs have very strong physics, chemistry, and mathematics departments. What that does is that when the student comes in, before he or she gets into their real field, they also have a good dose of science. Okay. And some of them now take minor areas in science. The parents force them to go into electrical engineering and so on. I'm just saying it in general. But their heart was in science, so they can now take a minor area. So these things can be done. Just to give you an example, there is a National Center for Biological Sciences in Bangalore. It's a TIFR sister institution. The director of that is a BTech of IIT Bombay in mechanical engineering and then did biology and all that business. And now he's heading a biosciences institute. So that does, these kind of things do happen. We have to encourage many more of these.
Thank you, Professor. Anybody else?
I'm delighted that 300 odd people are there. I'm sure they have questions. Don't be shy, please. Huh?
One student has asked a question. The recent inventions from Indian Institute of Science in Emerging Technologies. What are all?
So, if you're talking about the recent one by a professor called Navkant Bhatt, if that is the one you're referring to, he is actually a nanotechnology person, nanoelectronics person. And they have developed devices based on nanotechnology for diagnostics in the bio area. So this is where one science and one technology marries with another science, which is biosciences, to come up with a new device or new devices for the benefit of mankind. If that's the one you're referring to, or you have to tell me which one.
No, his question was in general. Some of the emerging technologies.
So this is one of them. If I'll take you back. Some of you may remember that IIT Bangalore came up with what is called a computer, which was a small computer. And in my opinion, it was a precursor to the handheld devices we have today. But somehow Indian ecosystem did not allow it to, or let it prosper, not giving it enough input. So lots of technologies in IIC Bangalore are there in many areas, bio, materials. Some of them end up resulting in papers, but a few of them do go. It depends on the professor and the student to take it forward and start an enterprise. But many times, unfortunately, professors are very satisfied with papers and not worry about businesses. But some of the students are, and that is why technology incubation centers in places like IIC or IIT Bombay, since I was there, not because of that, but what is called the Society for Innovation and Entrepreneurship is prospering, probably one of the best. They've had their first unicorn $1 billion company.
Thank you. Anybody else?
Good evening, Professor. I'm Selva Ganesh, Assistant Professor from Department of Electronics and Communication Engineering. So, shall I ask my question, sir?
Yeah, please.
Sir, my question is, as you have discussed, nowadays the innovation is more, but comparatively with the invention, it is very less. So, what kind of skill set the students should have, as well as we should develop with the students to make more number of inventions?
So, you have to give them ideas of what are new things that's happening in the world, and that will excite them. Sometimes you may have felt yourself when you see an invention in, let's say, electronics area, if you see the electronics, I could have thought of this, but you didn't. Now that ambience has to be created that you think of it before somebody else does. So it's an ecosystem which you have to develop. So one of the things I say as an offshoot of online education is going on. Okay, so people are taking courses online and this. But now is a time where you can interact with students one-on-one without wasting time to travel, but over the Zoom, and see what new ideas they may have and jointly develop that idea and take it forward. See, the students are raw, so they don't have enough knowledge. You have the knowledge, but they have the excitement and the energy to take it forward. So you have to synergize those two and move forward.
Yes, sir. We will incorporate that. I will incorporate that.
Yeah.
Thank you, sir.
Absolutely. And if need be, you can actually interact with, and they're all willing to do it, the IITs and IIC and all that, they're willing to interact with you to take things forward. Mind you, not everybody should go into inventions, innovation. Somebody should do basic work also. But my stress is that at least you think about it,
Yes, sir. Sure. Thank you, sir.
Professor, one more question is little more inputs on log9 from IIT Roorkee, that air aluminum battery.
Yes. These are two youngsters. Well, there are several now, but two youngsters who started this company in Bangalore. Actually, it's based out of Bangalore, and they have several inventions. I only mentioned one of them. Very innovative people. So what they did was, let me describe their journey to you. They had a summer training with some professors in Canada in the area of graphene. Okay, and they got fascinated by it. And they said, how can we use graphene to make some new products? So the first product they made was a sponge which is filled with graphene in a unique manner. It's not that straightforward, but in some technology. And you can put the sponge onto a oil spill on water, and it sucks up the water about 10 times faster than any other currently available device or before they came in. So that is one very simple but very useful, because you do hear of oil spills and so on. Then they made these electrodes with graphene. So graphene is the technology basically, and then electrodes are connected with aluminum, Aluminum gives the aluminum oxide in water through the transfer electrons, and that produces electricity, which charges, which basically it becomes a charging station, which charges the lithium battery in the car. So you don't require big lithium batteries, but which will make the car run for 100 odd kilometers. Then you stop and you say, okay, now our battery is gone. You throw the water out, fill it new water, put new aluminum plates, ready to go again. But it will take time. It has to be, it's water and all that, so it has to be packaged properly. The design of the battery should be will be different. Right now, they have this huge battery sitting in the back of the car, and you can sit in it and run. But it has to be a product which people can buy. So they are working on it. It'll take a year or so. They've made some new batteries which for electric scooters, electric motorcycles, which can go for a longer distance. So people are right now in the delivery mode. The motorcycle, if you have an electric motorcycle, it probably goes 50 kilometers. With their batteries, it goes 3 times the distance. So if you're delivering Domino's pizza, you can do much faster delivery. Charging time is much less, and you can do more deliveries. So these are things which are technology helping people.
Thank you, Professor. Anybody else? Any other questions?
Good evening, sir. This is Deepa Prabhu. I'm from the Biomedical Engineering Department. I had a question on the balance between research and innovation. So as an engineering and technology, the faculty who teaches engineering and technology, I see many students who have difficulties with mathematics. And the way I understand it, mathematics is the basic language of science. So many of the students try to do things superficially when it comes to innovation. So is there a certain amount of mathematics that we have to teach them so that they can become better innovators, or the system level understanding is sufficient for good technology to come out?
Yeah. So very good question. You know, for being a good or a very good scientist, you have to have knowledge of all the basic sciences, which includes physics, chemistry, math, biology. Earlier it used to be physics, chemistry, maths, or physics, chemistry, or biology. Now you have to know all 4 well. Okay? Because bio will not work without chemistry. Mathematics will not work without physics. Physics will not work without mathematics. And now we talk about biophysics, or you have the DNA, which is basically chemistry, bio, but also mathematics involved in its and physics involved in its making crystals and the like. So not everybody needs to be excellent in maths, but they should have basic knowledge. If somebody is not strong in maths, he or she will not make a data scientist, because that's where a lot of maths is required. But the data scientist who's very good at maths, if doesn't know much biology, he or she will not make a very good biomedical engineer or biotechnologist. But like you are in biomedical, so biomedical is such a large field. It has diagnostics. People working in electronics are working in biomedical. I mentioned about this nano electronics guy. People working in mechanical with the biophysics of all the how the bones and joints and all their work are into biomedical. Many areas. Drug delivery, biomedical. Making of the drug is different, but drug delivery is biomedical and the like. So today's world, the answer is that just knowing maths will not work. Just knowing biology will not work. You have to know more. You should work towards what your strength is if you want to go towards innovation. If you're weak in a subject, don't. I mean, there are so many things in this world to do. You don't have to go to your weakness. You have to go to your strength.
Yes, sir. Thank you.
But I must mention before you go further, if there are so many people, and I'm so delighted that so many people there. But if you have questions and you're shy or you're running out of time, you can send it to the principal, to the director, and you can compile them, and I will send you the answers.
I'll certainly take it, Professor. Probably I'll collect all the questions and then mail them to you, and then
Yes.
take your responses also and share it with the individuals. And we have also recorded your presentation, Professor, since this is on a WebEx call. So we will also be able
Okay.
to share it with as many students as possible, so that a good
Okay.
number of them will certainly be benefited as a motivation to think different, to innovate, so that they are able to grow and think in a different direction as well. If there are more questions, probably we will conclude. We take your questions, consolidate them, and
Yeah.
share it with Professor.
And I'll send you my presentation, PPD version.
Yes, yes, Professor. Yeah, I'm really getting, thank you, Ms. Chatbox. On behalf of the entire group of SREC, faculty and students, it's my privilege to extend my hearty thanks to Ashok Misra for the excellent presentation, sharing his, which are certainly very useful and beneficial to all of us. I look forward for more interactions, frequent interactions, and also for face-to-face discussions as well, Professor. Whenever things become slightly, probably I will invite you to visit our institution, visit our campus, look at some of our innovations which our students have done and things like that. Thank you very much, Professor, for your time.
It'll be a pleasure, and I would definitely come. But I quickly scanned through the chat box, and one question I'd like to answer. And
Yes,
they said somebody said that shouldn't innovation start at the school level? Absolutely right on. In the school level is where the child student can be trained to think out of the box, and that's what is needed. Yes, absolutely. You're right on. You should start at school level, college level, then it can be taken forward.
Thank you. Thank you very much, Professor.
Thank you so much for your patience, and lovely interacting with you.
Yeah.
Okay, bye.
Thank you. Thank you.